So welcome to the first video lesson of 2016. Chukmong nang moi. Keep practicing that, guys. So you guys, as promised, these are the network problems which will show up on your quiz, okay? Try to do your best to understand them, but they're very basic. They're very simple to understand if you understand what's happening. So basically, if you understand, like in class, I asked you this. I said, if 20 students came to class today, how many students will leave the class, right? Well, if 20 students came, that means 20 students will leave. Same thing with networks here, okay? What we're going to do is we're going to formulate a series of, like a linear system, basically, based on what's shown here. So they say solve the system for the traffic flow represented by x sub I, and I is 1 through 5. As you can see, there's traffic flows, and there's a network of 5, okay? Flow of traffic, vehicles per hour through a network of streets, and these are streets, and we're just trying to see how many what's the traffic flow, okay? So you guys, remember I told you, I said if 300 is going into this corner of the street here, right? Into this street, if 300 is going in, how much has to come out, right? So this first equation is this. Well, 300 went in. That means 300 has to come out. So this is number 84. So if you can't see this very clearly, you can check out your book. That means x plus 1, which is the outflow, right, has to equal 300. Because the input has to equal the output, right? That makes sense, okay? Now that we're done with this guy, okay? So we're done with this sucker here. Now let's move on to here. Now what's happening here? How much is going in? So you can also think of it this way. Anything that's going in would be positive, out would be negative. You could also think of it in the ways like whatever in has to equal out, okay? So you guys, in is x2. In is x2, is coming in, right? And who's coming in also? 200 is also coming in. Now, who's going out? In has to balance out with the out. So that side is in, this side is out. Out is x3, and x5 is going out. So you have that. But you guys, let's rearrange everything later, okay? Now, let's go to the other one here. Let's go to this sucker here. What's happening here? Who's going out? Let's do all the outbounds. Let's do inbounds first. In is coming in, x1 is coming in, x3 is coming in. But who's going out? 150 is coming out, and so is x sub 4, okay? Now, look at number 84 with me, okay? Let's go to this node here. Now, who's coming in? Who's coming out? In is x4. x5 is also flowing in. But who's going out? 350 is coming out. So that's going to equal that. So how many equations do we have? We have 4 equations total. So let's write these equations down. Okay, we have this guy here, that's the first. Second one is x sub 2 plus 200 equals x3 plus x5. I'm going to circle this one because it's in the right form. Let's have all the linear system, the actual terms on the left-hand side with the coefficients and the variables and all the constants on one side. We're going to rearrange the second equation here that came from this guy here. We're going to rearrange it so it becomes x2 minus x3 minus x5 is equal to 200. I'm sorry, negative 200, okay? Negative 200. All right, negative 200. That's our other equation here. That's our second equation. Our third equation here, which is for this sucker here. Okay, that one was x4 plus x sub 5 is equal to 350, and that one could stay as is. That's our equation. And we have this guy here, which was x1 came in, x3 came in, but 150 came out, and x4 came out. Let's rearrange this guy. So it's x1 plus x3 minus x4 is equal to 150. See, in is equal to out. That's all you have to worry about. Now you have a linear system here. So you have an idea what to do. So set up a ratio. Set up a matrix. So 1, 1, 0, 0, 0, and you have 300 here. Okay? You have another one, 1, 0, 1, negative 1, 0, and that's going to be 150. I'm just breaking up all the matrices I'm transferring this linear system into a matrix, okay? 0, 1, negative 1, 0, negative 1, and that's negative 200. And I have the last one, 0, 0, 0, 1, 1, which is going to be 350. All right. So you guys, when I compute the REF, here's what I get. When I do my REF, use a calculator, obviously, you get this. So REF of this problem is going to become 1, 0, 0, 0, 1, 1, 0, 0, 0, negative 1, 0, 0, 0, 1, 1, 0, 0, 0, 1, 0, and it's going to be 300, 150, 350, and 0. Okay? So we're here now. This is the REF, right? So let's write the equations that are for this REF, okay? So we have x1 plus x2 is equal to 300. We have x2 minus x3 plus x4 is equal to 150. We have, this guy says we have x4 plus x5 is equal to 350. We have, that's it, right? We have 3 equations, all right? Now, is that it? 1, 2, 3, 4. Okay? Oh, we have 4. 1, 2, 3, 4. Yeah, perfect. Okay? So now, it says here that x1. So now, part B. We're done with part A. Okay? A is done. Part B. It says, part B, what does it say to do? It says, part B, find the traffic flow when x sub 2 is 200 and x sub 3 is 50. That means x sub 2 is 200, x sub 3 is 50. Okay? That means if we're actually finding our 5, okay? 1, 2, 3, 4, 5, right? We already know that this is 200. We know this is 50. We're looking for x sub 1, x4, and x5. So let's go here. If you plug in x sub 1 has to equal 300 minus x sub 2, right? And that means x1 must be 100. So we have 100 for x sub 1. We're just plugging it back in, okay? This is the easy part. For x sub 4 now, x sub 4 here, right? We're going to use this equation here. X sub 2 minus, so it's 150 minus x sub 2 plus x sub 3, which is 150 minus 200 plus 50. So x sub 4 has to equal 0 there, okay? Now, so x sub 4 is 0, okay? Now x sub 5 is here. X sub 4 is 0. We're going to use this equation now. Well, x sub 4 plus x sub 5, it says it's 0. Well, if x sub 4 is 0, that means x sub 5 must also be, I'm sorry, this is 350, right? Sorry. 350, so x sub 5 must be 350, okay? So now, what you can do with these values is try this, okay? Now, you could do part C on your own, but try this. These values here, when you actually substitute it into these right here, it's going to actually all work out. So, for example, x sub 1 is like 100, right? So, put 100 here, put 200 here, put 50 here, and plus 0 and 350. You'll see that the input and the output are all going to balance out, okay? That's the general idea of network problems. But you guys, if you're actually doing a general equation, if I didn't tell you to make this true, what you would notice is that x sub 5 here could really be any real number. And x sub 3 also, because it's 0 here, okay? So I'll explain that to you in class, okay? All right, good luck with those network problems. Bye. We won't give you the most difficult cases for the test. For the quiz coming up. Adios.